Let's get started. This is me, Erik Gross. Thank you all for being here. I'm a senior level software engineer. I've been doing this for a long time. Love computers, love programming, and I love teaching. As I mentioned before, I've got experience in the Navy. I was a nuclear reactor operator and electronics technician and all-around nerd in the service. And that's actually where I found out that I like to teach. Didn't know that. They voluntold me that I was going to be an instructor, and I was scared, and then turns out I absolutely love it. I'm also the co-founder of the Tech Academy, and more on that later. All right, so in the chat, we have Christine, my assistant. She's awesome, and she monitors the chat, answers questions, is there to help both you and me. And please be nice to her. If you're not nice, we will boot you. Although it's been a long time since we had to do anything like that. So I say it every week, but I'm really honestly not worried about it. The people that sign up for these classes are uniformly awesome, nice people. Now, about these classes, we do a number of different types of free classes. This is a coding class. And I just want to point out that you might run into challenges while you're doing the coding. Part of the learning process is working through those. And I want to recommend that you use chat as needed. But I'll also say that we do our best to make this material approachable for people who have even like no experience in technology. But that said, we're here to help you. So use the chat as needed. One big thing I want to stress right now before we even get into the practical coding is that you should make sure that when we're doing the coding, creating a computer program, that you type the code exactly as written. Like I'll be typing it on the screen, you'll be able to see what I'm typing, and don't go fast. There's no need for hurrying. Just type it exactly the way I type it. And the reason for that is that computers are interesting. A misspelled word or a missing symbol or even something capitalized that shouldn't be capitalized can result in errors in your computer program. And we'll go over some of why that is. But just try to type exactly what's written on the screen. I don't see anybody who's joining from a mobile device. If anybody is there on a mobile device, you can listen, won't be able to actually do a lot of the coding because that's pretty difficult. Graham asks, is this recorded in case I want to revisit a portion of the seminar? Absolutely. And we put links, put the recordings of all these free classes up in our YouTube channel, and we'll give you links to all that at the end of the class. But absolutely, there'll be a recording of this. On this coding thing, I do recommend that you make sure you're in a distraction-free environment so you can really focus on the class, and that way I don't lose you, because I want you to get a lot of benefit out of this. I love teaching these, and just make sure you're in a distraction-free environment. If you are, when we're typing out all the code, if you fall behind, don't worry about it. Don't try to keep up if you're getting too far behind. Just listen and learn. Do stick around because you'll still learn a lot, even if you can't type out all of the code. On the video thing, the recording, by the way, that Graham was asking about, usually it's less than 24 hours before those get put up, okay? Also, you'll get the full code for the game that we're creating at the end of the class, and you'll be able to play the game, and you can take that code and tweak it and do whatever you want to with it, okay? All right, so I've already kind of checked on this. We've had a few people arrive. If you are new to these classes, like you've never attended one of the Tech Academy's free classes, drop into chat and let me know where you're joining us from. I'm in Portland, Oregon. So if you haven't already let me know tonight and you're new to the class, drop into the chat and let me know where you're joining us from. Give me an excuse to take a sip of water too. Oh, wow, the camera got really dark all of a sudden. Okay. Excellent. Sarah's joining us from Boston. Man, I got to visit Boston for the first time a couple years ago. Fell in love with that city. What a wonderful, wonderful town. Okay, good. Excellent. Well, welcome, everyone. All right. So basic agenda. We'll have a short explanation of the Tech Academy, the organization that puts on these free classes, and then we'll write code. And that's going to be the bulk of our time together is writing code, right? Now, I'm going to try to answer questions during the code writing, right? And time permitting, we'll also have a Q&A session right after we get done writing code. Then we'll go over some information about our boot camps, the offerings we have to help people break into the technology industry. And there is a free gift for everyone at the end, so please stick around. The whole class will be about an hour and a half. All right, so who is the Tech Academy? Well, we're a training company that delivers what are called coding boot camps. These are intensive technology certification programs. They're designed to prepare people for entry-level positions in the tech industry. Depending upon where you go, they typically last 3, 4, 5, 6 months. So they're pretty quick, and they focus on modern practical skills. Now, at the Tech Academy, we've been delivering boot camps, like thorough, budget-friendly, flexible, trusted coding boot camps for over a decade now. We were one of the first boot camp companies to come around, like way back in 2014. These programs we deliver are cost-effective, they're self-paced, they're fully online, and they are boot camps that are tailored for beginners, people that have no prior technical or coding knowledge, and more on that later. The programs cover in-demand skills for the tech industry. They're endorsed by stellar online reviews, and they're designed to fit around your personal schedule. We want to prepare you for your tech career with a well-rounded toolkit. In terms of pricing, the average cost of boot camps in America is around about $13,500. Ours are under the national average. They start as low as $5,300. And I'd like to read our mission statement here. The mission statement of the Tech Academy is to graduate entry-level technology professionals that excel in the basics of their field and thereafter have successful careers in the tech industry, and whose actions raise industry standards and surpass client expectations. So that's what we're all about. Our product is you working in tech. One service I want to let everybody know about that is relatively new, we just launched this a couple months ago, is called the Tech Academy Accelerator. Now, this is kind of unique. This is a monthly subscription service, and it includes 3 principal things. First of all, live weekly workshops with me that I'll tell you more about in a second. They're a lot of fun. Okay. The second thing is it includes access to over 100 educational videos. And the third thing is it includes access to over 100 self-paced online mini classes. Now, how does this differ from the boot camps and everything else we do? Well, this is meant to be an accelerator where you get access to me as like a decades experienced technologist to really accelerate your career, to move really fast. Okay. So the workshops we do are we'll build complete applications or lay out the entire blueprint for how to succeed as, an independent contractor, or, run your own agency in technology, all kinds of, we go really deep, right? When we do these workshops, there's lots of Q&A, it's open chat and voice, it's really collaborative. And I teach topics that are suggested by members of the accelerator community. So that's what the accelerator is. I love delivering it. Sorry, Zoom is being really, really funky. Okay. Hold on a second. Let me look at chat. Can you all still hear me? Give me a yes or a thumbs up in chat. Can you hear me? Awesome. Okay. Thank you. Okay. Let me go back. So again, on the accelerator, what's so much fun about it is that I really get a chance to just dump everything I know about a specific subject and really help people learn fast. It's a really cheap service. It's like $9.99 a month. And we've made it really easy to figure out whether you like it or not. Your first seven days are free. Christina, can you drop the link to join the accelerator into the chat? There we go. If you want to join, like I said, there's no risk. You get your first 7 days free. So fill out that form, really simple form. It will ask for, for card data, but you don't get charged for a week. So you can, try it out for a week, attend the next weekly workshop, which is next Tuesday, and see whether you like it or not. All right, so that's the accelerator. Now, let's get started. This is so much fun. I want to clear up a couple of terms that are, oriented around what this, this coding practice we're all going to do is about. So the first one is, what's a program? Well, a program is just a series of written instructions that you can put into a computer and then make the computer do things. In other words, you as a professional get to direct the behavior of a computer, which is pretty cool, right? So programming is just programming language is what we put into the computer. This is how we make the instructions. It's just a set of like words and phrases and symbols that allow you to communicate with the computer and tell it what to do. That's how programming works, right? Then there's coding. Coding is just the action of entering those instructions in. And you're going to do a lot of that tonight. You'll have a place where you can type in instructions, and then you can run the instructions. You can make the computer obey your directions, okay? And by the way, when you're doing that, code is the instructions you type. Coding is the activity of putting those instructions in. All right, so last thing I want to mention before we start coding is, actually, there's a little bit more orientation. Last thing I want to mention about like tonight's class is we're going to be using a language called Python. There are thousands of programming languages. Python is arguably the most popular one in the world, right? It's neck and neck with a few others, but it's very popular. It's been around for about 30 years, right? 35 years. And what's neat about it is it reads very much like English. It's very easy to kind of read it and figure out, what the program you're looking at is supposed to do. And it's really versatile. You can use it to create all sorts of programs like mobile applications or web pages or games, all kinds of things. So that's Python. All right, now, one of the things we figured out at the school, like over a decade of helping people break into tech, is if you throw people into coding right away without a little bit of orientation, it can be very overwhelming for them. So what I'm going to show you on this next slide is one of the most important points of orientation about programming that we've ever put together. And what it is the 5 elements of a computer program. And what I'm going to show you here is no matter what kind of computer program you're going to create, it will be made up of some combination of the 5 things I'm about to show you. And there aren't any other things that will be in that program. Whether it's a simple program or really complex, it's only ever made up of these 5 things. So if you can learn these 5 things, you'll be miles ahead in learning to code. So what are these 5 things? Well, the first one is an entrance point. In other words, when you start the program running, what's the first thing that happens? What's the very first instruction that the computer is supposed to do? And by the way, I apologize for why I'm getting dark and then light in my little video. No idea why in this office it gets all psychotic. I think it's when I drink a cup of water, it loses its mind. So let's go back to this entrance point thing. Yeah, when you write a program, there's got to be a very first instruction. Now, there's a lot of like really nerdy detail about why this is important, but here's the biggest one. When you are telling your computer, hey, run my program, your computer will do some things to help your program operate. One of the biggest ones is this. In the computer are devices, they're called memory devices, where you can store data. This is data or information that your program, like I said, they're called memory devices. You may have heard the term RAM. It means random access memory. It's just a little teeny physical device where electronic data can get stored. That's all it is. So why do I bring this up? Because when you start your program, your computer will find a section of inside that device with a bunch of little locations to store information, and it'll reserve them just for your program's use. It's called allocation. It allocates the memory. And that's a really important step for your computer program that you spend all this time creating to be able to run effectively. It needs access to, a place to store information that no other program is allowed to access, so that no other program can go in and mess up the information your program needs. And so that's why every program will have an exact entrance point. So your computer knows, hey, as soon as we hit this instruction, this very first instruction, set off a bunch of space in the memory device just for this program. So that's the first one. I'm going to try something here with a little bit of feedback. If that made sense to you, give me a 1 in the chat. If it was confusing, give me a 2. I got some 1s there. Excellent. All right, good. Let's move on to the second element of a computer program. It's what are called variables. Now, we already talked about the idea that your computer program is probably going to want to keep track of information or data. Here, we're talking about a program being able to keep track of data that can change while the computer program is running. And this is actually really important. If you go back 50 or 60 years to the dawn of the computer age, the first programs that were being created did not have this ability. Whatever information they were going to operate on was fixed. You'd create a program just to handle an exact set of information. And if that information changed, then you had to create a whole new program. So this is what variables are all about, okay? We'll go into how they work and everything. You're going to make some inside your program today, and that's what variables are. How do you keep track of information that's going to change while the program runs? All right, give me a 1 if that made sense, or a 2 if you need anything. All right, good. Excellent. Thanks for all the 1. Appreciate it. Okay, let's move on to the next one. Okay. All right. Now, before I explain this one, let me alert you to a technical difficulty that I just found out about 30 seconds ago. I just learned that in, let's see, 40 minutes, power to this entire building is going to get shut down. Didn't know that before we started the class. So I'm about to go a little more rapidly through some things. I'm going to endeavor to do everything I can to give you great experience. But if at any point you're lagging behind on the coding, just continue to stay on and learn and listen, and then we'll get the recording up to YouTube as fast as possible so you can follow along. So let's jump back into this. Control and branching. This means giving your program the ability to control making a decision, making a choice. In other words, if you have 2 possible courses of action, like let's say you can only sell a specific item to somebody if they're over 21. Well, you've got to have in your program a place where you can make that decision. They're over 21, so you go down this path, and they're under 21, so you go down this path. Your program has to have that ability. If not, it's not a very valuable program. Then the fourth, remember there's only 5 here. The fourth one is what are called subprograms, and these are fascinating. This is, like it says, a program within a program. We're going to build one of them tonight, but the big picture is that if you've got a series of steps that you're repeating over and over again the exact same way inside your program, then what we'll do is we'll take those set of steps and we'll put them inside a nice little box called a subprogram. And that way, whenever we need that set of steps to happen, we'll just call on that subprogram. It will do its job, and then we can go back to where we were when we left off. It's really valuable. And like I said, we're going to build one today. The last element of any computer program is what's called an exit point. It's an ending point. Now, again, there's a bunch of nerdy stuff that we don't need to get into. The big picture is this. Remember how I said on item number 1, the entrance point? When we started our program, the computer that is on reserved a bunch of memory device spaces and locations for it. Well, when the computer program is done running, the computer can unallocate those memory locations. It can make them available for other programs to use. And so the computer needs to have a final instruction, an instruction that says, hey, this program is over. Anything you were doing for this program, you can stop doing. So look at these 5 things. These 5 elements are the only things you'll find in any computer program. And the program will be made up of several of these, lots of variables, lots of control and branching statements, lots of subprograms, but that's all there is inside a computer program. All right, give me a 1 if all that made sense. Give me a 2 if it wasn't 100% clear. Awesome, bunch of 1s. Okay, good. Guna, if you could type in there the exact point that isn't 100% clear, I'll jump back to it and get you caught up and squared away. All right. Now, while she's typing that in, he or she, I apologize. I can't tell gender inside the chat. While they're typing that out, we're going to move on to the next thing. we need a place where we can enter in our code instructions. And what we have is a really cool little online code editor. And a code editor is, like I said, it's like a text place where you can type in your instructions and you can run them and see what happens. It's where you can practice your programming. Christina, if you can drop that link, the bit.ly / yeah, there it is. I want everybody to click on that link that Christine just dropped into chat. And this is going to take you to a code editor. And it's going to look like what you see on the left-hand side here. Oh, sorry, on the right-hand side. It's going to look like a little text area on the left. On the right is a window where you can have output. And we're going to use this a lot all day long. Now, this next part's really important. I want you to be able to see my screen and your code editor side by side. So you can see what I've typed and you can compare it and see what you typed. And it's very clear what to do. So set yourself up so you have my Zoom on the left and this new code editor you opened up on the right. Sometimes that's not 100% clear on how to do it. If Zoom is misbehaving, you can click on this little Zoom meeting words and another little drop down will come about. And the resize will let you resize the window and move it around. On the browser, it's the same thing. In the top right is this little symbol with two different windows on top of each other. That's a resize button. Either way, get yourself set up so that you have do these two things side by side. Graham says, can you utilize other text editors? Absolutely. If you're all set up to do Python in the text editor, use another one, right? For this one, it might even be easier to use this because it's so quick and simple. All right, so we're now going to jump into the coding. Okay, so we're going to build a choose your own adventure game. I'm going to demonstrate the game for a second here, okay? Let me escape. Here is the code. I'm going to paste this in, and we are going to play this game. So on the right-hand side, you'll all get this code, don't worry, okay? I just want to show you what it is we're actually building here. You find yourself in a mythical forest or mystical forest, a cliff looms to the left. What do you want to do? Walk off the cliff? No, I don't think that's really smart. Follow the path right. I'm going to follow the path right. So let me go with 2 here. Wise choice. Magical lake blocks your path. A whirlpool swirls dangerously. What am I going to do? Swim into the whirlpool? I mean, it says it's dangerous. I think I'm going to use levitation, just float across. Okay, all right, good. Wild bear confronts you. Try to wrestle the bear. Yeah. Oops, you died. Let's try that again. Okay, good. So I'm not going to play the whole game and everything, but you can see it's just a choose your own adventure type game, right? Don't worry about all this code over here. You'll be able to understand most of this by the time we're done with the class tonight. But I just wanted to show you the game, and you're going to get all this code. Now, we're not going to build this entire game. Frankly, it'd take hours to do so, and it actually wouldn't help you as much as what we're about to do. Here's what we're about to do. You remember those 5 things that I mentioned are like fundamental elements of any computer program. Oh, wait, am I sharing my screen still? Is this good? Let me look at chat. Can you see my screen? Yes or no? Awesome. Okay, good. Thank you. All right. Thanks, folks. Let me get the chat over here so I can kind of monitor what's going on. Okay. So you remember those 5 elements? We're going to build those 5 elements. There's 3 of them we're going to concentrate on a lot because they're the most important. That is variables, control and branching, and subprograms. But first, let's just start by writing an instruction. The first one, we're going to print something to the screen over on the right-hand side. So the command or the instruction inside Python to print something on the screen is print, P-R-I-N-T. Let me do a little control plus action here to make that bigger and easier to read. All right, so print, and put in open close parentheses like that, and then do a double quotes. The double quote is just to the left of your enter key typically. And don't type anything else. Let me explain what we're looking at right here. This print is a built-in Python instruction. The designer of the language knew that very commonly you'd want to display something to the screen, so we built an instruction called print. There's a couple of basic principles in Python I want to talk about right here. So this is going to sound rock bottom simple, but it's actually pretty important. Notice that this word print, we have an opened and closed parentheses right after it, and there's no space in between the instruction print and the beginning of the parentheses. And that's actually pretty important. Here's why. A lot of the times in Python, when you're trying to perform an instruction, that instruction needs some information in order to do its job. When that's the case, you'll put the instruction that the information it needs in parentheses immediately after the instruction. So we go print, which is the instruction, and immediately, I mean, no space, nothing. Immediately after that, we put open and close parentheses, and right inside those open and close parentheses, that's where we provide the information that this instruction needs to do its job. In this case, the information that's needed is some sort of text. We're going to display some text on the right-hand side, and text is usually inside of double quotes. So that's what we're set up for here. We just need to give it some information. Why don't we all give it hello world and an exclamation. And then you see this big arrow here, like a play. Hit that. That runs your program. And look, it works. We printed something there. All right, good. Now, the key takeaways. There are built-in instructions in the Python language. There's a lot of them, and you can learn learn details about it in a boot camp or lots of online resources, but there's a lot of built-in instructions. Many of those instructions require information in order to do their job. When you need to pass information in, you do it inside of open and closed parentheses. That's the key takeaway. All right. So now let's talk about variables. Remember I said that variables are a way to keep track of information that could change throughout a program's running. Well, let's say that we want to name our adventurer in our little choose your own adventure, right? So we need a name for the player. Let's create a variable called player. To do that in Python, all you do is type the name of the variable. So P-L-A-Y-E-R and hit a space. Now, with that simple instruction alone, we created a variable. Here's the best way to think of variables. Now, again, inside the computer is a little teeny device called a memory device. And there's little locations inside it where you can actually store information. But the best way to visualize it is that your memory location is a bucket. It's an individually numbered bucket. No two buckets have the same number. So you can identify the bucket. And on the outside of the bucket, you put some sort of a name. In this case, the name will say player. Inside the bucket, you put the information you're going to store. So there's two things that work here. There's the name for the variable, and then there's the value of the variable. In this case, the name is player, but we need to give it a value. And the way you give a variable a value is by using the symbol equals and then a space, and then you put in what value do you want to be stored there. In this case, we want our player to be, well, our name. So do a double quote and type your name. And that's how you create a variable and then give it a value. Now let's use that variable. Because look, go ahead and run your program right now. And all it does is just do this print hello world. This other instruction right here didn't actually produce any output because we didn't tell the program to produce any output. Let's produce some output. Go ahead and hit enter a couple of times. And by the way, you don't have to have this blank line in between instructions. I'm doing that to make it a little easier to read your code. So let's use this variable. Let's print the name of the player on the screen. Let's do the print like we did before. Remember, this particular instruction needs information to do its job, and we put the instruction inside of open close parentheses. So type some open close parentheses. But inside the parentheses, we're not going to put text like we did up here. Instead, we're just going to put the variable in there. Type P-L-A-Y-E-R. That's the name of our variable. And what Python does, when you give it the variable to this instruction called print, it looks in the memory location called player, and it reaches in and grabs the value that's stored there. In this case, the value is this text word Erik, or whatever you put in as your name. So run this, and it'll print your name over on the right-hand side. So we've now created a variable and given it a value. Well, big deal. But it is a big deal. What if the player changes their name? Let's change the name of the player. Type your variable, P-L-A-Y-E-R again, and then another equals, and let's give it a different value. For everybody, I want it to be called George. Our player is now George. And now go to the end, and let's print it again. P-R-I-N-T, and let's print player. Just like we did before. We are now working with a variable. We're working with a piece of data that can change as our computer program runs. And I know I'm using a very simple example here, but it's really, really valuable to have this inside a computer program. So that's a variable. Now, in order to give ourselves a little more room to work with, I'm going to delete all these lines here, or otherwise my screen's going to rapidly fill up. By the way, if you do that and run it, you notice the computer program runs the exact same way. I just did that to make it a little bit easier to see what we're talking about. All right, so we've talked about variables. Now let's talk about control and branching. So there's two separate words there. So there's two separate things that you'll need in your program. This control and branching is all about putting a way in your program for a decision to be made. It's the classic, like, if this, then that. It's like if, then else. Like if age is greater than 21, if age is 21 or greater, then sell them the alcohol. If not, don't sell them the alcohol. I know it's a horrible example. Okay, but it's one that most people understand. So you're putting in your program a way for a decision to be made. And here's the more important part. You're also putting in the program what to do based on that decision. What are the two or more possible, things to be done? Well, they call those, quote unquote, things to be done, the instructions to do. They call them branches. Think of your program as one main set of instructions you do, 1, 2, 3, 4, but then you get to a decision point. At that decision point, there's two or more sets of instructions that can be done. Those sets of instructions are called branches. That's why we call it control and branches. Let's control which branch we do. Now, we're going to build one of these. And essentially, we're going to build what happens if they choose option 1, 2, or we have two different options. We'll make it very simple. If they choose option 1, then something happens. If they choose option 2, something happens. We'll just make something up. Let's say that their choice, they have to make a choice. It says, do you want to do action 1 or action 2? So we need a variable to hold what their choice was. So let's make a variable called choice. So just type choice, that's the name of your variable. And let's pretend they chose option 1. Let's print right before that, P-R-I-N-T, jump in the lake. One equals yes, 2 equals no. Let's run this and make sure that it can print. Look at that, it says jump in the lake. 1 equals yes, 2 equals no. All right, so what do? We've given them a choice. let's pretend that they've chosen number 1. So, unfortunately, there's a deadly monster in the lake. So if they jump in, they're going to die. So we did choice was equal to 1. That's what they chose. Now we need to give them, we need to force our program to make a decision. And it works like this. There's an instruction in Python called if. So type if. Now, if needs information in order to do its job, just like our print did. But the information that the if needs is a decision, a true or false, a yes or no. So what we need here is, if their choice is 1, then we're going to print out, sorry, you died. If the choice was 2, we're going to print out, you survived. So the way to do this inside this parentheses we have is hit space and hit equals twice, and then hit space, and then I'll explain what we're looking at. 2 equal signs together are a very special symbol in Python. What they are is it's actually an instruction. It tells Python, listen, on either side of this symbol, you have 2 pieces of data. Compare them and tell me whether or not they're equal to each other. If they are, then this is a true condition. If they're not, it's a false condition. When we type it out, it'll make a little more sense. Go right back to right after the parentheses, and we're going to compare the value of the variable called choice, so spell it correctly, then go all the way to the right before the end parentheses, and type a 1. Now this reads like English. It says if the variable called choice is equal to 1, that reads like English. That's nice. Now, what we need to do now is we need to give the set of instructions to do if they entered 1. The way to do that is this. It's a special symbol in Python, which is the colon. Put a colon at the end of that line, and I'll tell you what that does. This is super important to learning Python. Remember how I said that we need to have at least 2 branches of instructions or 2 branches of code? We're going to have 2 here. One branch of code is if they chose 1. Another branch of code is if they chose 2. Well, the branches, like the sets of instructions to do, they're called code blocks. We need to make a block of code that's only to be performed in a given situation. And then another block of code that is only to be performed in a given situation. So this is called a code block. We're about to create a block of code. We're about to create the instructions to do if they in fact chose option 1. In Python, and this is the critical thing, in Python, the blocks of code underneath an if are indented. They're spaced over by a couple of spaces. Watch what happens when you hit enter. Notice that this code editor, having detected the fact that we put a colon on the line before, has moved the cursor over by 2 spaces. We're about ready to type the code block, the set of instructions that are only going to happen if the person chose option 1. What do we want to do? Well, we want to print sorry you died. So PRANT, like we did before, give yourself the open close parentheses, put some double quotes, and say sorry you died. Like that. Now, in chat, I want you to put, what do you think is going to happen when we run this code? Don't run the code. Don't cheat. Put in the chat, what do you think is going to be printed out when we run this code? What do you think? Drop it in the chat. Lee, that's a really good guess. Unfortunately, the program, he says it's going to give you an input option. It actually isn't. We do not have, in this particular code editor, a nice, easy way to ask for user input. We're just going to print this. Jump in the lake, 1 yes, 2 no. Line 8 pretends that we got some user input. Good, Van. Van says, since choice equals 1, then we're going to say, sorry, you died. So that was a perfectly good thought, Lee. Is like, well, aren't we going to ask them? And we aren't building that part of the code just because it's a little more complex to do and doesn't serve the learning experience. Ideally, you would do that. And in fact, in the full code, we do that. So go ahead and run this. And you see, yeah, it says, sorry, you died. Good. Well, now we need to put in, what do you do if they don't choose 1? If they choose 2, here's how you do that. Go to the end of the sorry you died line, hit enter. And this is super important. We need to use an instruction called else, E-L-S-E. E-L-S-E. So type that in. But this part's super important. We can't put this else instruction exactly where it is. And what I mean is, it can't be lined up with the print instruction, because then it's part of the code block, the instructions that are only going to happen if choice equals 1. We're about to make another decision. We want to make that decision either way. So what you do is backspace and put this else on the same level as the if. And then hit it, colon, hit enter. And the else works the same way. It needs a code block underneath. You read this, like, this is how it reads in English. If the choice is equal to 1, then do what's inside this code block. Otherwise, do what's inside this code block we're about to create. What do we want to do with this code block? Well, let's just print, yay, you lived. So print, yay, you lived. That's it. So, don't run this yet. In chat, put down what you think is going to happen when we run this code. What's the last thing that's going to be printed on the right-hand side when we run this code? Van says it's still going to say, sorry you died. Absolutely. Let's run it. And it still says, sorry you died. All right, now, let's go back up and change it to 2. And run it. And now it says, yay, you lived. So here's one of the big takeaways. You have to learn to think like a computer. A computer starts with one instruction and does it. When it's done doing it, it moves on to the next one. Then it moves to the next one. Then to the next one. So when we get to right here on line 9, immediately prior to this, we put the value of the variable choice equals 2. So now when we go to line 9, choice is not equal to 1, so we do not perform line 10. We instead jump to 11, and it says, all right, well, choice wasn't equal to 1, otherwise do this, and we do it. And this, even though it's a very simple example, you'll use this pattern over and over again in your computer programs. You use a control instruction. In this case, if it's a control instruction, else is a control instruction. And you combine control instructions with some sort of a condition, a true or false condition. This is a true or false condition. Choice is either equal to 1 or it's not. There's no ambiguity there. It's very cut and dry. Either choice is equal to 1 or it isn't. And if it is, then here's a block of code to perform. And if it, right here, here's a block of code to perform if it is. And if it isn't, here's a block of code to perform. So this is how it works to make these decisions, these control decisions, and then these branches. This is a branch, and here's a different branch. All right, give me a 1 in chat if that made sense to you. Give me a 2 if it isn't that clear. All right, got some 1s there. That's excellent. Okay, good. Now, let's go on to my favorite part of this, which is this thing called subprogram. If you recall, a subprogram is kind of like a program within a program. And let me explain why this even matters. In the early days of making computer programs, I'm talking like 50, 60 years ago, okay? Programmers would be creating the instructions in a program, and they would find this certain thing was happening over and over again. No matter what project they were working on, this exact thing I'm about to describe would keep on happening. Here's what it is they'd be creating a program, and they would find that there was this exact series of steps they were doing that were identical every single time. There might be like 5 instructions that were the exact same step every single time. And they might do them 50 times in a big giant program, like a specific way to print something to the screen or something like that. There's just a set of instructions that never changed and were done the exact same way every single time. And at a certain point, they went, man, this is such a waste of my time to type the exact same set of instructions. And here's the part that really stinks is if they wanted to change up how those 5 steps were done, they had to go look through the program and find every single time they used that exact set of 5 instructions and change it in every single location. It was very error prone, very time consuming. And so they came up with this idea of a subprogram. And it was basically this. We've got this set of instructions that we're going to do the same way every single time. Why don't we put them off into their own little like container, give the container a name, and then whenever we need that set of instructions, we'll just call on the name of that container. And we'll do those instructions and then come back where we were when we left off. Because it is, but it's super powerful. So these are subprograms. Now, like I said before, there's thousands of different programming languages out there, thousands of programming languages. And there's several different names for this concept of a subprogram. Some languages, they call it a subprogram. Sometimes they call it a function or a method or a subroutine, but it's all the same concept. So we're going to make one. And we're going to make a set of instructions that basically every time they come up to a lake gives them this same option. Because let's say the text adventure game has like 50 different lakes they might encounter. Well, you don't want to make this set of instructions right here over and over and over and over and over again. You don't want to do that. We want to be able to just say, hey, they bumped into a lake. Please just run these 6 instructions and not have to type them out. So we're going to make a subprogram that does this. It prints jump in the lake, yes or no. And then it takes their choice and it gives them the response to the choice. We're going to put that into a subprogram. Now, again, in Python, we call a subprogram a function. We're going to make a function that we can use every time our player encounters a lake. So the way you make a function inside of Python is you use an instruction called def. That means define. So type your def and hit a space. Now we didn't need a name for this function. We're going to call it lake. That's all. It's just called lake. Don't hit space after that though. Here's one of the most important elements in Python. One of the more important. I know this. I don't think lots of things are important, but this is important. When you create a function, you need to specify whether or not that function needs any information in order to do its job. Remember that when we use this print function, and that's built into Python, when we use this print function, it does need information to do its job. It needs something that is text or a variable that has a text value. Print can't do its job if you don't give it any information. Well, you're the programmer. You're about to make a function. You get to decide whether or not it actually needs any information in order to do its job. Now, in this case, it absolutely does. It needs to know, what did the person type? What was their choice? We printed jump in the lake. We need to know what they said. So what we'll do is we'll put in parentheses the name for the information they're going to receive. and we're going to call it choice. They're going to receive a choice. The user typed 1 or they typed 2. Our function needs that information. So go to the end. This part's super important. Ready? We're about to create the series of instructions that'll be done, and this is really critical. We're about to create the series of instructions that'll be performed only when this function really gets called on. The instructions we're about to build won't happen automatically. These instructions we're about to create will only happen if our program calls on this function. So let's go ahead and make the instructions. Put a colon because we're about to put a block of instructions that are inside the function. Hit enter. And notice that this code editor is friendly. It just moved over 2 spaces because we're about to make a code block. Now, I don't know about you, but I don't want to spend a bunch of time typing all this out. So I want you to copy these 4 lines and keep them highlighted for a second so you know which ones to copy. Okay, now don't paste them yet. I want to explain something. When you paste this in, only the first of these 4 lines is going to be indented properly, just because of how the paste function works. So copy them, those 4 lines, go down here, notice that we're indented by a space, and I want you to paste. Now notice this first line was indented properly. These 3 lines are not. So highlight all those 3 or select those 3 lines, and then just hit the tab button. And it moves them over properly. And leave that highlighted so you can see what I did. I grabbed 3 of those 4 lines and I hit tab to move them over. And now you'll see it's formatted right. I'll explain that again. This colon says, hey, Python, I'm about to give you a code block. I'm about to give you the instructions that you'll only perform if this function is called. That's what the colon is. Underneath it, indented, is the set of code. The first line's indented, only 2 spaces. But then we have another colon. So this line of code has to be indented. Then we're done with this branch. And so our control instruction, else, is only indented to 2 spaces. Then we have a colon. So the branch is indented 4 spaces. Again, notice how this reads. Once you learn the formatting rules, it reads like English. We've defined a function. The name of the function is lake. The function takes a piece of data called choice. When we call on the function, we check on the value of the variable called choice. And if it's equal to 1, then we perform this code block. Otherwise, we perform this code block. This is how Python works. And again, once you get used to it, it does read pretty much like English. All right, now, we won't get this function called lake to run unless we call on it. So how do you do that? Go down to the very bottom, hit enter, but remember to backspace a couple of times. So we're back to where we need to be to enter an instruction. And let's call on the function called lake. You do that by literally typing the name of the function lake, 1 or 2. Let's say they chose 1. Let's say they jumped in the lake. Run this code. Notice that the final answer, sorry you died. That's because they chose 1 right here. That's what this line right here, line 20, represents, is they chose 1. Well, later on, go to the bottom here, hit enter. Let's say they encounter another lake and they chose 2. Run this. And this time they lived. We now have the ability with 1 line of code, with 1 instruction, to perform these 4 lines over and over and over and over again. And that's where programming gets really cool. Again, I know it's a really simple example, but notice that this function we built shows two principal aspects of a program. One, the subprogram. It itself is like a set of instructions you can repeat over and over again. And two, inside there, we have control and branching statements. If is a control instruction, else is a control instruction. We've got branches. We have specific conditions. So like I said, I know they're very simple examples, but they demonstrate the fundamental elements of any computer program. This is how you get a program to make decisions. This is how you get a program to have repeatable steps that are really easy to do over and over again. All right, give me a 1 in chat. Oh, wait, Taylor says, how did you add the drop-down arrows for line 11? Oh, I didn't. All that is a nice little feature inside. Notice that it's 11, 12, and 13. If you click on it, it'll collapse the lines of code. Yeah, the code editor does that because you might have a really, really long function. Like notice that this one right here, on the definition of the function called lake, when I click it, the whole function definition disappears. It's just to make your programming experience a little more easy to manage, because you might have a huge function that takes up like half a page, and sometimes you just want to collapse it down for readability. It doesn't delete anything, it just collapses it. Does that answer that question? Okay, good. Excellent, Taylor. All right. Okay, good. So now I want to give you all a chance to use this game. First, I'm going to give you this. Actually, Christine, if you've got it, can you drop the link to the full code inside of the chat? And by the way, if I lose power and I lose you all, I'm so sorry. We'll probably have to pick this up again next time, or I really want you to come to the next coding class if we drop this. I don't know what's going to happen with power in this building right now. Okay, good. So Christine just dropped this link in there, and when you click on that, you should see what I'm looking at right here, this full text-based Python game-free class code, okay? I want you to Control-Alt and select that, and then Control-C to copy it. However you do it, copy all that code, and go back over to your code editor, and copy what's in there and delete it, and paste in the code. Replace it with the code. Now, we're going to go through this code in a minute, but first, just play the game for a minute. Just play the game. I'm going to pause for a second, get a sip of water, and I want to see. I want you all to experience playing the game. That was weird. When I said get a sip of water, Siri turned on my phone. No idea what that's all about. Listen here. Listen here. All right. When you played the game for a couple of turns and kind of got the hang of it, give me a 1 in chat to let me know you've had a chance to play the game for a little bit. All right, got 1 there. All right, this one's okay. So let me just point out a couple of things in this code. Let's all just take a look at this code. The first thing I want to show you is right at the top. Now, we didn't talk about this yet. Just from the color formatting, you can probably tell that import is a Python instruction. All of our Python instructions have been, what is it, magenta or purple or whatever. This particular instruction tells Python to bring in a set of code that's outside of this particular code. In this case, random is a set of code that people created years ago that provides various functions. Remember how we built functions? We built our own function called Lake. Well, this particular set of code has functions in it that can generate random numbers, which can be valuable. We need that for our program. So this instruction just says, hey, bring in this set of code called random so we can use it. Now, if you start to look in here, you can see, well, we're defining some functions. There's a DEF. We define a function called init. And then if you scroll down, we define a function called shuffle options. another function called play step. You can see from the name of the functions, they kind of indicate what they do. Shuffle some options. You can play a step of the game. There's a function for when you end the game. And there's a function for starting the game. Huh. Okay, good. And then right down here, this is where we start the game. So again, I know there's a lot more stuff in there, but you can already start to see that you can understand a bit more of what this code is all about. And it only is made up of the 5 elements we talked about. It's got subprograms, like there's, remember, defining functions, that's a subprogram. It's got variables. Well, let's look at some variables here, all right? Well, score is a variable. We're checking whether or not score is greater than or equal to 15. This is what this means, is greater than or equal to. And look, this is a control and branching instruction right here. It's saying if score is greater than or equal to 15, hey, we got a high score, print this. So there's control and branching in here. So you can start to read through Python code and understand at least a little bit of what's going on. All right, now, I will point out that a graduate of our boot camps will be able to read through this whole thing and understand all of it, and in fact, could create this program and much more complex programs. Okay, so let's go back here. Give ourselves a all right, can you all see my, oh, it's popping A, right? Well, I'll say Q&A in a second. Get F11 going here, make it larger. All right, Q&A. Give me a yes in chat if you can see the Q&A slide. Awesome, excellent, thanks. Okay, so let's do a little bit of that because we haven't lost power. If you have any questions that we haven't covered yet, drop them in the chat right now. I'm gonna grab more water. Nope, I'm out of water. All right. So let me take this opportunity to tell you a bit more about who and what we are. And by the way, stick around. We've got your free gift coming. Okay. So really briefly, at the school, at the Tech Academy, we have like 12 online boot camps. And you can see on the screen here, they cover a lot of different areas, a wide range of technology subjects. We cover artificial intelligence, computer programming, website development, cybersecurity, which is super important right now, design, data science, video game development, mobile app development. In fact, we've got more certification programs than any other coding bootcamp on the planet. And while I could talk for an hour about the way these boot camps are run, I just want to let you know this about the programs. They're self-paced, yet also instructor supported. They're flexible. Students set their own study schedule, and you can enroll any day of the year. The content on them is really well-rounded and in-depth. They're affordable. All of them, all the programs include both job placement training, like how do I get hired in tech, and job placement assistance, experts to help you go through that process. But most importantly, all these programs are designed for absolute beginners. No technology knowledge or experience is required to get through one of the programs, so you don't have to be a nerd. And who are these programs for? Well, they're for anyone looking for a better career. As we'll talk about in a second, technology is a great industry to work in. There's remote work opportunities, it allows for better work-life balance, it pays well. So that's what we're all about. And we've been recognized for it. We consistently land on every major best coding bootcamp list out there. We also have really good reviews. In fact, our average review rating across all the major bootcamp review sites is 4.8 out of 5 stars. And those are based on student and graduate feedback, which we're really proud of. So I'm going to elaborate a little bit on like why you might consider working in tech. Here, you all signed up for a free coding class. There's probably some level of like interest or curiosity about the tech industry. Now, I've worked in it for decades. And so I can tell you a couple of things about it. One, generally, people who work in tech have really good work-life balance. And especially now, post-COVID, remote work is a very real possibility for a lot of people working in tech, which is pretty cool. It's also a really creative industry. You work with machines, yes, computers are machines, but the work we do is very creative. The problem solving, the collaboration is awesome, and you can take a lot of pride in what you do. It's also a really stable industry that pays well. Most of you probably know that. Tech jobs pay well. I'll tell you more specifically about that in a second. And if you apply yourself and keep learning, there's regular increases in pay. All right, now, how do you break into tech? Well, I know a lot about doing the boot camp route, and I can tell you there are some barriers to getting through, like getting into a boot camp and finishing them. I'm not naive about that. One of the biggest ones is the money. A boot camp tuition costs thousands of dollars. What we've done to try to make that a bit easier to confront and handle is we have multiple financing options, including a really big upfront discount. Or if you need to make monthly payments, there's options for no credit or bad credit. There's an option for everyone, no matter what your situation is. But the thing I want to point out about this is, yeah, this is the money aspect of it. But the fact is, if you enroll in and get through a Tech Academy boot camp, it's genuinely an investment in yourself. Obviously, I've got a biased point of view, but I've helped thousands of people break into tech, and I'm telling you, if you give yourself that gift of certainty about your ability to work in tech, you've got job prospects for the rest of your life. It's really, really cool. Now, there's another barrier, which is time. There's a lot to learn. Even though you're learning like the key things you need that employers want right now, there's a finite amount of stuff you need to learn. There's still a decent amount of stuff. Some programs out there, some boot camps handle this by running their trainees in what's called a cohort. No matter when you sign up, everybody starts on the same day. And they all move through the material at the exact same pace. I could talk to you for hours about how I disagree with that approach, but I understand why they're doing it. Other boot camps require you to study in person to make sure you're like put in the right time. We don't do that. Our programs are fully online, so you don't have to show up to a physical office if you don't want to. And you choose your study schedule. We recognize that people have lives, so part-time study is totally allowed, and you can study concurrent to holding down a job or going to regular school. Finally, another barrier to getting through a boot camp is you probably need to have some technical interest or ability. And this is a critical one. All too often, I've talked to people who don't feel like technology is for them because when they started to study it, it felt like the materials were too hard or difficult, or they felt stupid. And I'm here to tell you the problem is not with you. The problem is with materials. A lot of educators assume too much knowledge on the part of the student. We don't do that. You don't have to be a nerd to get through our programs. In fact, like I said before, there's no background in coding or tech that's required to enroll. I love this. Van says, coding definitely makes me feel stupid, but only when I figure the problems out. I know exactly the feeling you're talking about. You're bumping up against something, you're trying to solve it, and you finally get it, you're like, why didn't I see that an hour ago? But it also feels really good when you solve it. It's really cool. Okay, that was really cool, Van. I appreciate that. Van also says, then it's just a typo, one typo. Yes. Van asked a good question. On the AI side of technology, artificial intelligence side of tech, is remote work still a real possibility? Absolutely, 1,000%. I know a lot of people who work in AI, they work fully remotely. And we have AI graduates because one of our options is the AI bootcamp. And yes, they can get remote work. All right. So here's a question for you. Like here you are, you signed up for a coding bootcamp and went through, you learned a little bit of stuff. There's probably a reason for it. Are you working in a dead-end job? I'm not like to disparage the job you have. Maybe it's a perfectly fine job, but by dead end, I mean that the income, the peak income you can make in that kind of job doesn't match what you want out of life. That's a dead end job. If you want to make $100, $150, $200,000 a year, and you know that the industry you're working in will never get you to that point, for what you need in life, that could be considered a dead end job. Maybe you're even unemployed right now. Or maybe it's really important you want to work from home. And the work you're in right now, its very nature would never let you work remotely. Or maybe you want just more time with loved ones, some balance there. In other words, and this is a personal question, is it time for a career change? If it is, the Tech Academy is the solution. We're career change experts. That orange bridge you see in our logo is there for a reason. We've worked hard to be the route into technology for everyone. And at this point, we have over a decade of experience in helping people break into tech. How well do they do? Well, most Tech Academy graduates, on average, make $30 an hour in their first job. That's $60,000 a year. That may be a little to you. It may be a lot to you. It depends on your experience. But I can tell you that if you're starting at like $60,000 a year, which is what $30 an hour is, and you apply yourself, within a few years, you're breaking 6 digits over 100,000. You keep working at it, and 125, 150, 200 is very real. And we know this because at this point, we have over 1,000 graduates working in tech, and everywhere from small mom and pop businesses to medium-sized business to really big internationally known companies like Nike and Facebook and Disney and Uber and Epic Games. So as a reminder, at the school, we have open enrollment. You can start anytime. So I encourage you to enroll now. Christine, can you drop that link into chat? And I'm going to tell you something very special about the month of June. All right, so we piloted this last month and it did really well. We decided to extend it for 1 month, okay? For students who enroll this month in June, one, if you can handle the tuition up front, you get 50% off of the tuition. That's many, many, many thousands of dollars in savings. And if you pay up front like that and you don't happen to have a laptop, we can send you a refurbished laptop for free. Now, that's only for US students. We don't ship, out of the country for the laptop. So again, if you pay up front, 50% off your tuition. And this is a this month only thing. Okay? Second thing, no matter where you live, you're not going to get charged sales tax. If there is sales tax where you live, we will pay that for you. Third thing, and this can be really helpful, we'll send you physical copies of all of our books to help you get through technology. We've written a lot of books, my co-founder and I, including an Introduction to Coding book, our Computers and Technology Simplified book. I'll tell you more about that in a minute. And this is really cool, a Technology Basics Dictionary, which with simple, clear, easy to understand definitions for thousands of technology terms. That took us years to put that together. This next one is really, it's something I wish I had years ago. Jack and I, my co-founder and I, put together a career planning guide, which is essentially a blueprint for how to navigate the first 3 years of your career. Don't get me wrong, that day that you break into tech and you've got your first job, it feels fantastic. It feels really, really good. But after that wears off, you're like, oh, how do I control and plan my career over the next few years? And so we laid down in this book every single action to take and when to take it in the first 6 months, the first 18 months, in the first 36 months, exactly how to plan your career. And I've never seen anything like this. We're really proud of it. And you get a free copy of that when you when you enroll this month. The other thing we're throwing in is 3 months of free access to that Tech Academy Accelerator, that subscription service with workshops with me and the mini courses and the online videos and all that kind of stuff. Okay, it's just included for 3 months. We want you to be part of that community because it really does help you progress faster. And finally, and this one's huge. Man, this is really we had to really think long and hard about whether we're going to offer this. Unlimited job placement assistance. What that means is if you've gotten through the program and you're on the job search part of it, we will stick with you as long as it takes until you get hired. And that's huge because our job placement personnel and the technology and the know-how we've compiled about how to get hired is huge. Kim says, you introduced us to job hiring companies after attending the boot camp. We absolutely do. We've got connections in a lot of different places. And I tell you this, what we realized, and Kim, I appreciate the question. What we realized about 10 years ago is learning to code and learning how to get a job in technology are two different disciplines. They're two separate bodies of knowledge. And we recognize that you need a separate course just to learn how to get hired in technology. And that's the final course you do. It's called the job placement course. And we require that you do that training before you're even allowed to work with our job placement specialists, because it's so critical to learn that know-how. But once you know that, one, you know it forever. And two, when you work with our job placement specialists, it's so much more effective. It's so much effective. And Van has a really good point. He says, getting hired in anything, I feel like a class is needed. You're absolutely right. And the truth is, what you learn in that job placement class, it'll apply to whatever industry. But I tell you what, this is a hard-won knowledge. We've been doing this a decade, and every single time we learn one more new thing to make it more effective for people on doing job placement, we put it into the class, and we made sure all of our job placement personnel knew that, so we could help people guide, through it. So I just want to stress that this final thing on this slide, the fact that we're giving unlimited job placement assistance, is really a big deal. Our guys and girls that work in job placement are very good at what they do. All right, so again, that's a June only thing. So, and by the way, stick around for your free gift. You'll be here in just a second. If you want to learn more, that link is in the chat, right? And when you submit the form, it's a really simple form. What comes after it is a simple series of steps about the Tech Academy. There's videos in there about our approach, our training methodology, the different boot camps, like details about what's on each boot camp. There's articles in there that describe all this stuff. And there's even a step in there if you want to book a call with our admissions personnel. So what I recommend is fill out the form right now, and then after the event, go through those steps. In fact, I'll wait a second for anybody who wants to click on that link, and I've got to get a little more water. Kim asked a really good question. I want to just address it head on. She also asked, she asked that great question. Do you introduce us to job hiring companies after attending the boot camp? The answer is yes, absolutely. And then said, or do you give a guarantee we can find a job with a certification? We do not give a job guarantee, and we never have. And I've never seen a reputable company that will, only because the fact is, it's you in that interview, and we can't be in there with you. Every once in a while, we'll get somebody that no matter all the training they do, no matter how much help we give them, they won't interview well. They've got a personality thing. It's very rare. It's very rare. But because we can't be in that room doing the interview for you, we can't guarantee that part of it. But what we can say is, if you are pushing on it, if you are like endeavoring every day for the job application process and the interviews and the prep and all that kind of stuff, we will never let go of you. We will not, like it says, unlimited job placement assistance. We're there with you all the way until you get it done, until you get that job. One attendee says, my son is 9 years old, homeschooled, interested in coding. Will this be a good boot camp for him? Unfortunately not. Our license doesn't let us teach anybody under 18. I wish it did. I will say this. We have a book, a coding book for kids, and you'll see a detail on that in a moment here. It's a great place to start for kids. We've had hundreds of kids go through this book, and it's really, really effective. All right, let's move on, because I want to get you to the point where we get your gift. I want to mention that a thing about referral commissions, because our graduates love us. And so for years, referrals have been one of our top sources for enrollments. And so years ago, we instituted payment for that, a commission payment, 5% commission payment for all referred enrollments, right? So that's not just for our graduates. You can do that too. In a minute, we're going to give you an email to get your upcoming free gift. On the email you send us, you can include name and contact information for people you refer. We keep track of that, and we pay commissions for it. There's a person on staff here that's their sole job is keeping track of referrals and paying commissions. Sabita asks, is this program for people with some coding knowledge or for total beginners? Total beginners. Now, if you've got some experience, it just means that certain portions of the program might go a little faster for you. But absolutely, the vast majority of our students have not ever coded before. They don't have any technology experience, and they get through just fine, and they get hired. So absolutely, it's for total beginners. That's a good question, Sabita. All right, now I mentioned these books, and for the attendee who has a child, I really want you to pay attention to that one on the second one from the left. We have 7 books, 3 Learn Coding Basics in Hours books. That coding book for kids and young adults, the Python one, is awesome. We have a Technology Basics Dictionary, a Project Management Handbook that shows you how software gets made, which is cool, and then a phenomenal book called You Are Not Stupid. This took us about a year and a half to write. It's basically a written version of our most popular course called the Computer Basics course. Every boot camp, the first course is this Computer Basics course. It removes all mystery and confusion from every aspect of computers and technology, and we put all that into a book, plus a whole lot more. So that's what You Are Not Stupid is all about. It's awesome. All right, free gift. This is a Python class. We want to give you our Python coding book, and it's an actual physical book we're going to send to you. It's really good. It goes into a lot more detail about the 5 fundamental elements of any computer program. It goes into a lot more detail about the Python language, all of its different elements, and you do a lot of coding as you work your way through the book. And it's our gift to you for attending class today, which, again, I really appreciate. So how do you get it? Well, grab that email. Christina, can you drop that email in the chat? There you go. Just send us an email. Send an email to books@learncodinganywhere.com asking for your copy of the Python book, and we will send it to you, an actual physical book. Now, unfortunately, this is only for people who live in America, students in the US only, okay? And you have to give us your mailing address. We're not going to do anything with it, untoward. First and last name, and your full mailing address, and we'll send you a copy of your book. Also, if there's any more questions you have, put them in that email. They'll get forwarded to me, like technology questions. I love answering those. And if you've got people you want to refer to us, put them in there. We'll keep track of it and send you a commission, right? Amira, unfortunately, the answer to that is no. I go into a lot of detail about why, but I love that you want to do that. But yeah, we won't do that. Only our instructors actually work with them. Okay, good. So there it is, books@learncodinganywhere.com. Send us the email if you want a copy of the book. And finally, links. We mentioned we'd send out links. Here's how to get access to all links related to the Tech Academy. In a second, Christina's going to drop our Linktree link. If you're not familiar with Linktree, it's just a place to put all your links in one spot on the web. It's really cool. And you have links in there. There it is. To go ahead and click on that. You'll see it's got links to our free educational YouTube video playlist, links to our books, our dictionary, upcoming meetups. If you want to know about classes in the future, all the links are in there. All of our social media, right? Guna says, something about a username and password. I'm not sure what that is. Christina, can you find out what she means? Okay, good. Or what he means. So this is our link tree. Here's all of our links. Please follow us on social media. And also, if you want your own copy of You Are Not Stupid, an actual physical copy sent to your house, we give one of these away every single week. And here's how to get in the running to win one. It's really simple. Post a link on social media to our next event. Just go to the meetup link there, find the link to our next event, and share it on your social media and tag us. Tag the Tech Academy. Obviously, we're going to be notified immediately because it was a tag on us, right? We keep track of those, and we pick one of those people every week at random to win their own copy of You Are Not Stupid. I'd love to do that. All right. Thank you so much for your time. We did it. I didn't lose power. We hit it at an hour and a half, right? Really appreciate you all for attending this and for the response in the chat. I hope you got something out of it. Love to see you in our next class, right? And as a reminder, if you filled out that form to learn more about our boot camps, then do those steps afterwards. Find out more about the programs and how we work and all that kind of stuff. Absolutely. Thank you, Amira. Appreciate it. So glad I could be here to help you all. And please come to our next class. Y'all are awesome. All right. Have a good evening. I'm going to stop sharing. Bye, all.